Hello and welcome to today's class. This class will look at how to apply all the concepts we have learned from the introduction of indices, right? To look at how to apply this concept in solving this particular problem. So combine all the laws inside and solve this problem here. By the way, before we proceed, if you're interested in watching our previous class or the introduction to indices, simply check the description of this video. I'll drop a link that will take you to our initial class or perhaps or the introduction to indices. Let's solve this problem here. Let's start number one there. For number one problem, for number one there, I have 5 to power x times 25 to power x minus 1 all over what there? 125 to power x plus 1. So I have this. My very first task here is quite simple. I'll try to express each term there in terms of 5, because I can see that I can express 25 in terms of 5. I can still express 125 in terms of 5. So I express all of them in what? In terms of the same base. So we know that 25 we give 5 square, 125 we give 5 to power 3, right? So I'll insert this stuff here inside this. So this gives 5 to power x times 25 is what? 5 squared into x minus 1. So I have this all over, this is 125, that's what? 5 cubed into x plus 1. So I have this. At this point now, what's my obviously next task? My next task is quite simple. Observe this one now. Is telling me a law of indices here. This becomes what? A power law of indices, right? So I'm multiplying this stuff together. So I have 5 to power x times 5 to power 2 times x. We give 2x minus 2 times 1 is of course 2. So I have this all over. This is what? 5 to power 3x plus 3. Of course, 3 times x is 3x plus 3 times 1 is of course 3. So I have this. Now my numerator is showing me something. Check out 4. Look at the numerator. What is telling you? When like bases are multiplying, simply what they had their power. So I had the power. So what do I get from there? 5 to power x plus what? 2x minus 3. 2x minus 2 perhaps. So I have this. So all over, we said I'll have 5 to power what? 3x plus 3. So I have this. These two are dividing now. So let me just take this down to what we know. This can be expressed as 5 to power x plus 2x minus 2 divided by 5 to power 3x plus 3. This one and this are still the same thing, but I just break it down to what we know. Now go back to your division law of indices. When two bases or when two like bases are dividing, we said what? Subtract their power. So it becomes, I'll pick out just a single 5, then I'll have everything here. X plus 2x minus 2. But we said I'll minus from the what? Everything. That becomes minus into 3x plus 3. Ensure that you encase 3x plus 3 in a bracket, please, to avoid confusion, please. So I have this. From here, I'll have 5. This x plus 2x was 3x. Next up, minus 2. Minus times 3x is what? Minus 3x. I'll use minus to expand the bracket. Minus plus 3 is what? Minus 3x. So this one here will cancel this one. Plus 3x plus 3x is of course 0. So it's off. I'll be left with what? 5 to power minus 2 minus 3, which will give 5 to power minus 5. By the way, this becomes your idea behind the negative law of indices. For negative law of indices, we said the minus here becomes an inverse of what? 5 to power what? 5. So I have this is equal to 1 over 5 to power 5 will give about 5 to power 5 should give about 3125. 3125. This becomes my answer after simplifying the first example. Let's do example 2, please. For number 2 there, I have the third root of 64 r to power minus 6 half this way. My very first task is to simplify this. How do I get this done? It's a quite easy task. My very first procedure here is simple. To simplify this, I can do it in different way, right? At this point at your level in math, it's not a must the way I do my solving is the same you do your solving. So at this level in math, you can do your solving any way and you still be correct. So I'm saying that at this level now, you can solve problems in different dimension and still be correct. So I can choose to go with left or right. I'm still correct. So let's look at how to solve this one, please. I can choose to pick out the inside one first. So for the inside one there, I have 64 r to minus 6, then r to power half this way. Let me break this down. Look at this. I can infer one particular rule from the law of indices. Check. What rule am I inferring from here? Go back to your last rule. What's the last rule there? The product power law. Check your power law. When different things are multiplying, we said what there? Attach what? The power to each of them. So this becomes 64 to power half times what? R to power minus 6 times what? Times half. So I have this. This gives what? Root 64, right? Half we give square root of 64, as we said from an idea of fractional index law. So times, this is what? Of course, if I have minus 6 times half, 2 here 1, 2 here 3. So I have minus 3 times 1, it gives r to power minus 3. So the square root of 64 is of course 8. So I have 8r to power minus 3. So simplifying the bracket alone, I have this. What will not be the real answer to this particular question here? My answer now will easily become, per se, this example 2, right? Example 2. All right, from here now, what do I possibly get? The task is quite simple. I'll have the third root of what there? Of this one said from here down here is 8r to power minus 3. So I have 8r to power minus 3 after simplifying. So take this third root to back to indices. So I'll have 8r to power minus 3 or to power 1 over 3 this way. From indices now, this now take us back to the same concept we applied here initially, right? That when different things are multiplying, just attach the power to each of them. So that gives about 8 to power 1 over 3 times r to power minus 3 times 1 over 3. Attach the power to each of the term. This gives the third root of 8 times, this is 3 here 1, 3 here 1. 1 times minus 1 times 1 is gives r to power minus 1. Of course, we hold now, we know that the third root of 8 is of course 2. But if I made the word third root of 8, it means look for 3 numbers. Third root means 3 numbers that are the same, that when they multiply together to give you 8. That's 2 times 2, 4 times 2, 8. So I'm using 2. So the third root of 8 here is 2 times, go back to your negative index law. This minus becomes 1 over r this way. So this gives what? 2 over r as being my answer to that particular problem. Let's look at yet the final example and we're off. So I have 225 to power half plus 85 to power 0. So I have this, right? Multiply 256, right, to power minus 1 over 4. So what do I get with this? When we solved this problem here, we try to express everything in terms of 5, 5, 5, the same base. But in this case here, it's not easy to express them in the same base here. So what do I do in this case here? I'll solve them individually, right? So I'll pick out this one, 225 to power half. This means what? This root of what? 225, which is of course 15. So I have this. Pick out the second one there. I have 85 to power 0. This becomes your zeroth law of indices that says any number to the power 0 is of course 1. So 85 to power 0 will give just 1. I have this. Similarly, I have 256 left to power minus 1 over 4. Now, when I'm having a negative index, so that becomes a law under indices, a negative index law. We said the negative becomes an inverse of what? 256 to power what? 1 over 4. I have this. This gives about 1 over, I'll take the fourth root of what? 256. That's the meaning. 256 to power 4 means fourth root of 256. So what I get from here, this is now equal to 1 over, from the idea of fourth root of 256, I'll look for four numbers. Fourth root means four number that will be the same thing. When this four number multiply to give us 256, the number is 4. 4 times 4 times 4 times 4 is of course 256. So I'll have 4 here. So while expressing this one, I have 1 over 4. I'll put each value inside this back. So for me, I will have 225 half gives what? 15. So I have 15 plus, this gives of course 1. I have 1 times this one gives 1 over 4. 1 over 4. So finally what I get here, 15 plus 1 is of course 16 times 1 over 4. 4 here 1, 4 here 4. I'm left with what? 4 times 1, which of course 4. So it becomes my answer to that particular problem after applying the idea of indices. So we solve several examples in our next class. So do well to like this video, subscribe to my channel, share to your friends and classmates so they can learn too. See you in the next class.